Stellar black holes. Stellar black holes form when a massive star, typically at least 20 times more massive than the Sun, reaches the end of its life. In a supernova explosion, the star's core collapses into an incredibly dense object, creating a black hole with gravity so intense that not even light can escape. These black holes usually have masses ranging from 3 to 100 times that of the Sun. Although they can't be seen directly, their presence is revealed by the way they influence nearby stars and gas. For example, gas pulled from a companion star heats up and emits X-rays that can be detected from space. Supermassive black holes. Found at the centers of galaxies, including our own Milky Way, supermassive black holes are true cosmic giants. The one nearest to us, known as Sagittarius A, has a mass of roughly 4 million suns. Some supermassive black holes can tip the scales at billions of solar masses. Scientists believe these colossal objects grow over time by swallowing gas and merging with other black holes. When they draw in huge amounts of matter, they can power quasars, extremely bright galactic centers visible from across the universe. Intermediate mass black holes. Falling between stellar and supermassive black holes, intermediate mass black holes typically weigh in at between 100 and 100,000 times the mass of the Sun. They're rarer and more elusive, with some researchers suggesting they might be hiding in globular clusters, dense groups of ancient stars, or in the cores of young, small galaxies. Possible formation scenarios include the merging of several stellar black holes, the gradual accumulation of gas in a localized region, or the direct collapse of huge clouds of gas without forming a star first. Primordial black holes. Primordial black holes are a theoretical possibility, thought to have formed shortly after the Big Bang when the universe was extremely hot and dense. Unlike their star-born counterparts, these black holes could have originated in regions with unusually high concentrations of matter. If they do exist, their sizes could vary dramatically, from smaller than Earth to larger than the Sun. Some theories even suggest that primordial black holes might account for part of the dark matter that appears to govern the dynamics of galaxies. Studying them could offer fresh insights into the early universe, the birth of cosmic structures, and the nature of gravity. Types of black holes based on properties. In addition to their size, black holes can also be classified by other characteristics, such as rotation and electric charge. Schwarzschild black holes. These do not rotate and do not have an electric charge. They are the simplest form of black hole, characterized only by their mass. They are often found in the center of remnants of supernovae and are considered the basic model for understanding other types of black holes. Kerr black holes. These rotate rapidly and drag space around them, creating an effect called frame dragging, which deforms the surrounding spacetime. This effect can influence the behavior of matter and light nearby, generating luminous accretion disks. Reissner-Nordström black holes. These have an electric charge but do not rotate. Their charge influences the behavior of matter and light in the vicinity, creating an intense electric field that could repel charged particles. Kerr-Newman black holes. These are both rotating and electrically charged, making them the most complex. The combination of mass, rotation, and charge creates unique gravitational effects that are still under study, opening the possibility for theoretical scenarios related to wormholes and connections between parallel universes. Why study black holes? Studying black holes is important because it helps us better understand the fundamental laws of nature, particularly gravity and the behavior of space and time under extreme conditions. They can also give us clues about the formation of the universe and what happens to matter and energy in extreme environments. Furthermore, analyzing black holes allows scientists to test physical theories, such as general relativity, and search for new connections with quantum physics, which might reveal still unknown secrets of the universe. What is the event horizon? The event horizon is the boundary around a black hole beyond which nothing can escape, not even light. It is like an invisible line. Once crossed, everything is inevitably pulled toward the center of the black hole. You can think of the event horizon as the surface of an extremely powerful waterfall. If you stay at a distance, you can pull away, but if you get too close and cross a certain point, the current becomes so strong that returning is impossible. This boundary is crucial for understanding black holes because it marks the limit beyond which we can no longer obtain information about what happens inside. What happens if you enter a black hole? Here are possible theories. Spaghettification. Due to the extremely strong gravity, the body would be stretched vertically and compressed horizontally in a process called spaghettification. radiation. This happens because the gravitational force is much stronger on the feet than on the head, progressively stretching the body. Wormholes. Some scientists hypothesize that a black hole could be connected to a white hole via a wormhole, creating a theoretical passage between 2 points in the universe or even between different universes. However, there is no concrete evidence for the existence of wormholes, and if they did exist, they might be highly unstable, collapsing before anything could pass through them. Hawking radiation and evaporation. Stephen Hawking proposed that black holes are not completely eternal, but over time, they can lose mass through a process called Hawking radiation. This happens because pairs of particles and antiparticles spontaneously form near the event horizon. Normally, these particles would annihilate each other, but if one falls into the black hole and the other escapes, the black hole loses some of its energy. Over billions of years, this phenomenon could cause the black hole to completely evaporate, slowly releasing some of the traces of what fell inside. If you have any questions about this topic, feel free to leave them in the comment section. I also invite you to subscribe to the channel and watch the recommended video to expand your knowledge. See you there.